Good morning, good afternoon, good evening, wherever you are. Welcome to this math video from who we're gonna talk about breaking free by using the brain, and then I don't know what then, but yeah, be free, huh? So we're gonna see. We live in a world. We can see things. We can see things through a lens or a crystal ball, and then we have like an object, and we see the object in our mind a different way. And one of the ways to put down the reality into your brain is by inversion. This inversion, the circle of inversion is this, and the radius squared, that's just one of the things you can do, is the origin to point A times the origin to point A bracketed from the real object. So all points C, B, A, or any point on the real object can be displayed into your little computer like this. So when we take control of reality, and this is in our control room, let's say, and we like blow it up in the real world, the real object will be blown up. And even if the object stays the same, but we pull it near our origin, the object will blow up. And if we blow up the object, it will come closer to the edge of the circle, and the other object will also blow up. But if we blow it up too much, we get to the circle, it will come bigger, even bigger than our. This is what happens, you guys, when you take perception of the world. So here it is. This line over here is like a wall of infinity in front of you. The reality of what is coming, all of it. This line is going up endlessly down forever. And how are we going to perceive this in our crystal ball? In our circle? Well, like this. We can see this. So we can see all of infinity with our crystal ball. And if we go further, we pull it into our origin, it will bend, and the circle outside of our mind or computer will be like huge or even infinite. And if objects will come and collide with us, our perceived notice of this object will slide out. It's all very interesting. Now this one formula, it's called the circle of inversion, and all points within the real object will be displayed in the object, in the virtual object. Hint. So our reality, the one we are here, this is the cave, blah blah blah, Plato. We need to get out. We need to get out of it. We're here, 3D, you got left, right, and up and down, and you got back and fro. We go further. So we explore our world, and we explore it with our mind. So our world is over here, but we don't understand, we're on a planet. It was a beautiful planet, by the way. It will be again when the world is over. But we go here. This is understandable for us. Pi, that crazy number, 3.14, on and on. The simple circle divided by the diameter. Crazy shit. And then we go to the 1D world. Not even a line, not even a circle, just a point. And on that number line, on that space, pi rooted is equal to -1/2 factorialized. Factorization is related to root pi, and to pi, of course. So other examples of worlds, the 0D world, no dimensions, it's curled up. Every dude on this planet knows that. So it's also related to pi, of course. Just an example. And the curled up worlds, oh yeah, this one is curled up, whatever, I don't know, it's a different curl, blah blah blah, blah blah blah, it goes on, Okay. Let's focus on factorialization. What is factorialization? Factorialization is nothing else than the number times the number -1, -2, -3, -1, -4, -5, until you are at the one is central in this little puzzle. So 6 factorialized is 1 times 2 times 3 times 4 times 5 times 6. And 1 times 2 is 2. 1 times 2 times 3 is 6. 1 times 2 times 3 times 4 is 24. And 1 times 2 times 3 times 4 times 5 is 120. And 1 times 2 times 3 times 4 times 3 is 720, as we see here. And if we do like 12 factorialized is 1 times... I'm not going to do that one. We don't do that one, but have fun. Okay, so factorialization, what am I doing here? What does it have to relate to pi? Well, I don't know, but get your calculator out, because it's gonna rock you world. So, as I said, factorialization is nothing else than going to the 1, minus y is minus 3, 2, 1, blah, 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 every time. So, 7 is 1 times 2 times 3 times 6 times 7. Next. X plus a half factorialized, we were getting into it the other minute, is this plus this times this, blah, 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 to the 1, divided by 2 to the power x plus 1, times root pi. Yes, and this is the trick. So every number you can put in for x, it doesn't matter. You can make an accurate product with the root pi. So a root pi is related to pi to x plus a half factorialized. But what then is x plus a quarter factorialized? Well, all this is calculated with the Gamma equation. And this example of such a graph, you can find it on the internet. And like here is the deepest point of this graph on the number line. And that number would be like this also, but also a half. So, and yeah, okay, whatever. Here we have numbers, and here we have equation, blah blah blah. But this one, explanation factorialized, is almost equal to this one, because they are in this barrel. So one is over here and one over here. Here's 1, 0, here's 1, they are equal. 1, 0 factorialized, and 1 factorialized is both 1. So we go on with a quarter factorialized with the Gamma equation that I have explained over here. Freaky shit happens. This minus 3/3 is related to this, and still root pi. We're gonna use root pi every time because that is our goal, to explore our reality and see what pi does. So the Gamma n plus 1/4 is pi root pi, pi to the power of a half, that's root pi, divided by 4 to the power n, times 4k to the way, blah blah blah, plus 1, all those numbers. Okay, so we fill in a 4 for the n. 4.25 factorialized is 17 divided by 4, 13, next over 4, minus 4 is 9, minus 4 is 5, and minus 4 it will be 1/4, but you don't do that because 1/4 is lower than 1. You don't want to go there. Divided by 2 to the power 3/3, like was said over here. That crazy number is from the computer, but it is correct. And if we go on to like 1/8, we see that yeah, there's another number, minus 7/4, also related to this. If you can see, 3/3, 7/4, pi root pi, and another product. So here we go. 3.18 as an example. 0.18 is this, but we're gonna calculate this one. 33, because 2 times 4 times 8 plus 1, 3 times 8 plus 1, 2 times 8 plus 1, 1 times 8 plus 1 divided by 8 times, yeah, okay, I give it the Gamma equation from a quarter. That is over here. That is like the root of this, and the root of that is like pi. So where are we going with this? Well, to everything, the future, the Gamma of just a little bit, like a little tiny little thing, not 1/8, even more tiny than 1/8, like 1 divided by infinity. Like it's omega times the Gamma equation, omega minus 1 factorialized. So we're gonna figure this out. Why?